In the last video, we talked about the steps of a formal hypothesis test. Let's see them again one by one. First step is to state the null and alternative hypothesis. We have done that. Compute the value of the test statistic using sample values. Compute the p-value using the value of the test statistic. And then compare the p-value with the chosen level of significance and state the conclusion. Steps 2 and 3 will be seen in greater detail when we talk about the different statistical tests already. And in step 4, we're going to see and compare the p-values. Now, if you're going to look closely, we have some words that we're not familiar with. Test statistic, p-value, level of significance. So let's look at them one by one. Level of significance, symbolized by alpha, is the maximum probability of rejecting HO when HO is true. This is the probability of the test making a wrong decision. Because remember, we do not want to reject HO when HO is actually true. Of course, we don't want to accept the false statement. We don't want to reject HO, but HO is true. What we want is to accept what is true. But since we are not examining the entire population, only this one, the sample, we cannot really be sure whether the values of the sample would be true for the entire population. Hence, we have to give a probability that we will make a mistake, but we don't want a big probability of us making the mistake. That's why we have to limit and give a maximum value of the probability of rejecting HO. And that maximum probability of making the mistake of rejecting HO is known as the level of significance, or alpha. The next term is the test statistic. The test statistic is the numerical value obtained from a statistical test. As you all know, since we're going to use Microsoft Excel to compute for our values, we will point it out once we go to those video lectures what the test statistic would be. And then we have the p-value. The p-value is the probability of a particular test statistic or a more extreme sample statistic occurring if the null hypothesis is true. Say for example, we have the null hypothesis that the mean is equal to 7 days. Now, if this is the mean, but a particular test statistic, say for example, the mean from a sample that we got is 10.5 days. If this has a big probability of happening, when this is true, then that probability that we're talking about is what we call the p-value. The p-value will be the determinant whether we will reject or not reject the null hypothesis. And again, we will compare the p-value to the level of significance. The usual values for the level of significance are within the interval 0 to 0.10. And the most common of these values are 0.10, 0.05, and 0.01. 0.010 and 0.05 are usually dealt in the social sciences, education, business, and other related fields. However, 0.01 is usually for the medical and other health-related fields. Because we are dealing with life, we want to make more accurate tests and less errors or less mistakes. And the rule for the p-value approach is that if the p-value is lower, this would mean is lower or smaller than the level of significance, then we should reject HO. One way to remember this is the phrase, if the P is low, the null must go. Meaning, if the P is lower than alpha, then the null must go or must be rejected. So again, in our example a while ago, if the null hypothesis is that the mean is 7 days, and the p-value that we will be computing is, let's say, 0.06. The alpha that was set is 0.05. Oh, and by the way, alpha is usually given or is usually set in problems. So, comparing here, we can see that 0.06 is actually not lower or smaller than 0.05. Therefore, we will not reject HO because the computed p-value is not actually smaller than the level of significance. However, let's say we have the null hypothesis is 7 days, but the p-value computed is 0.02 and the alpha that was set is 0.05. Since 0.02 is smaller than 0.05, then the decision here is we have to reject HO, and therefore we are forced to conclude the alternative hypothesis. But remember, conclusions from a hypothesis test are not always correct. Because hypothesis tests are based only for sample information, we must allow for the possibility of errors in the conclusion. And we're going to talk about errors in the conclusion in the next video.